Okay, now that we've learned a little bit about the enthalpy, the standard enthalpies of formation, we're going to learn how we can use them to find the enthalpy change for any reaction that we want to. And it works really, it's a really slick method. This is all we got to do. The enthalpy change for any reaction can be found. So wait, let me just symbolize this. The enthalpy change for a reaction. So we're going to symbolize that delta H for a particular reaction can be determined by taking the standard enthalpy of formation of the reactants. Sorry, I had that backwards. I always do that backwards. For the products, and subtracting the standard enthalpy of formation of the reactants. I'm going to demonstrate this with a really simple set of equations so you can just sort of see how this works. So let's say I want to find the enthalpy for this particular reaction. Let's go for boiling water. So I'm going to go for H2O liquid going to H2O gas. And to do this, we're going to put two ideas together. We're going to stick Hess's law together along with the standard enthalpy of formations. So what I'm going to do is I'm going to write the standard enthalpy of formation of gaseous water. So we've already done that. That's going to look like this. H2 gas plus half O2 gas. That's going to go to H2O gas. And if we look this up in the chart, you're going to see that the enthalpy of formation for gaseous water, that's going to be negative 242 kilojoules for every mole of gaseous water. And notice, that's our product. Now let's find the standard enthalpy of formation for liquid water. Well, it's going to look the same. I mean, this whole equation is going to look the same, except we're going to have a liquid here. So we'll just write that out. But of course, because we're making liquid water and not gaseous water, this is going to be a little bit different. We're going to have a different value there. So if I look that up in the chart for liquid water, well, where are you? Well, I just had it. Why am I having trouble finding hydrogen? Here we go. H2O liquid. That's minus 286 kilojoules. So the formation of liquid water releases a little more energy. You know, we're starting with the same stuff, but when we go to liquid water, a little more energy is released than when we start with the same reactants and go to gaseous water. Now, we should note that if I reverse this second reaction, I'll be able to recover this original equation. So if I flip this, I'm going to need to flip the sign of this, and we'll write this as follows. H2O liquid, of course that's going to go to H2 gas plus half O2 gas. Now we're going to add these two together. And look what happens when we do that. When I add these two together, hey look, I've got an H2 gas on the reactant side and an H2 gas on the product side. Those can cancel. Here I have a half O2 on the reactant side and a half O2 on the product side. Those can cancel. Now you might think I can cancel these, but you have to remember you can only cancel things that are the same chemical in the same state. And this is H2O liquid going to H2O gas. They're not in the same state, so I can't cancel them. But notice that these equations are now identical. And so because I added these two equations together to get this equation, I'm going to add these two equations together to get the enthalpy for this particular change. That's going to be a positive, for this reaction, it's a positive 44 kilojoules for every mole of water that boils. I'm going to stop and make sure this makes sense. Let's see, to make water to go from a liquid to a gas, I have to put energy in, don't I? So it makes sense that my delta H is positive. So we're finally at the point where we can see what we're trying to get at with this particular sequence here, that the enthalpy change for a reaction can be determined by taking the enthalpy of formation of the products. Well, let's see, what's my enthalpy change in my products? That's this one, isn't it? See, here's my product in the reaction that I want, and this is the equation that corresponds to the enthalpy of formation of my product. I leave it the way that it is, and we're going to take that and we're going to subtract from it the enthalpy of formation of the reactants. Let's see, what's my reactant? Well, my reactant is H2O liquid. And notice, we took the enthalpy of formation of liquid water and we reversed it, or we subtracted it. Remember, I had to change this sign. And so this can be actually written in the following way. The enthalpy change of a reaction is going to be equal to the enthalpy of formation of the products. You just leave those the way they are because those equations are written with the products where they are. But we're going to have to subtract the enthalpy of formation of the reactants, because those need to be flipped in order to get what's normally written as a product in the enthalpy of formation. We gotta move them over to the reactant side to get our particular equation that we're looking for.